interoperability problems you find particularly exciting. So this is something that we as test managers really have to look at, is how do we properly equip our test lab with those things that we need to interoperate with, because our customers need to interoperate with them. This means also a more creative way of thinking about tools for test automation. The idea that we're just going to pound away on the GUI of a particular application, and that's going to allow us to figure out what we think we need to figure out from a test point of view, that's really not going to work for a system of systems. I use this phrase, testing both sides of the sandwich, and what I mean by that is if we look at an end-to-end situation, take applying for a home equity loan, for example, or any sort of loan from a bank. This is the initial interaction might be through a GUI online, but there's a whole lot of stuff that's going to happen in the data center behind that in terms of interaction with decisioning mainframes and all sorts of other systems. And ultimately, out the other end of that process comes some sort of loan paperwork. What you would want to be able to do is follow that entire transaction through in an automated fashion to the point of actually comparing data that was entered on a screen to some sort of optical character recognition of a PDF of the final paperwork coming out of the back end of the process and checking that the data matches, right? And that this is very sophisticated stuff. Now, it's possible to do it. We have done it for clients before, but it's way beyond the typical sort of capture playback tool demo that you're likely to get standing in a tool expo at a conference or something like that, or see online. But this is really what we need to be able to do when we're testing systems to systems. Now, in a systems of systems testing world, the tester needs to master the various test fundamentals. The practice of bringing in a user or setting up a test team of a band of users or former users or tech support people and saying, okay, well, you guys understand the application, so you guys are the test team. We've seen this done in clients that have systems of systems, and it does not work. And at least not if that's the only thing you do. Those users or tech support people are going to need to be trained in how to do good testing, because we see such test teams tend to have a lot of ineffectiveness and inefficiency. Yes, they know the application, and yes, knowing the application in the business domain is important. But many times they only know their own application, and they need to be upskilled in terms of the other applications that are in the data center. And they also need to know how to do basic test design, and so that they don't write a lot of redundant tests. And we had one client that pursued that sort of expert user strategy for creating tests, and later when some of those people were trained in testing fundamentals, they went back and found that more than half of their test cases were redundant. They were covering things that were already covered by other tests. This is the application of a very simple technique, equivalence partitioning. So, you want to be effective and efficient. And efficient, of course, in a downturn economy like ours is very important. So, this understanding of how to design tests that aren't redundant is very important. Technologies, the technologies continue to get more and more diverse. We have legacy applications in many cases that have been around for a long time. I was just talking to a client this week that was talking about a project that was converting from an IMS database accessed by a COBOL application. And are just now converting away from that to a DB2 database that's going to be accessed with, it might be still COBOL, or maybe it's something newer, but this is some old school stuff. And at the same time, they have Java-based applications and web-based stuff going on. So there's a very diverse mix of technologies that you need to understand. And finally, this issue of what I call the lifecycle wars. There's a lot of debate, and I'm going to wade into it a little bit later about agile versus sequential, and agile versus more formalized iterative models like RUP and so forth. And these debates can go on and on. But when you get into systems of systems and interoperability of systems and stuff, a lot of this stuff is it's just beside the point. What you've got is a collection of applications that are going through their own software development life cycles, and those need to be meshed, and they are going to be disparate life cycles, not necessarily synchronized. And so, how do we deal with that in a constructive and pragmatic fashion, not a dogmatic fashion of saying, well, just if everybody in the whole world went agile, then all of our problems would go away. Okay, now open source. Open source is great. A lot of great stuff has come out of open source. You think of the developer testing side, things like JUnit and CPP unit, good stuff. And you've got Firefox, the browser, and Linux, and there's a lot of good stuff, and a lot of good things that for us as test managers too, of freeware tools that we can kind of collect. And I've built a lot of test frameworks, harnesses with TCL, sometimes called Tickle, other kinds of free open source components floating around out there on the internet. Great building blocks for test systems. But when we start talking about not just building test systems out of open source, but actually the system under test being built in part out of open source, you got to ask yourself, well, was that formally tested? Now, I think you can assume that something that comes from, for example, Red Hat, a release of Linux coming from Red Hat, has gone through some testing. Something you download from SourceForge.net, though, is it tested? Has it been formally tested? What are we doing with it, too? It's how exposed are we? A tool that is downloaded off of, for example, SourceForge.net that is used by your programmers as a utility to build the applications that are actually used in the data center or sold to your customers is a much lower risk entity, if you will, than something that you're going to download and use in your data center. So you have to ask yourself, well, what's the risk if this doesn't work, right? We have the issue of system integration testing of these things. You've got a collection of disparate applications, as I was talking about before, and if these are open source and these are put into your data center, well, okay, we can be pretty sure that even if some of them were formally tested, that they probably were not tested for the specific use cases and combinations that you have in mind. So, the system of systems challenge with open source is exacerbated by the fact that there's really nobody on the back end of that transaction that you could reasonably expect had tested all the different things that you're likely to be doing with it. Estimation is going to be tricky. They've got a lot of organizations relying on these old rules of thumb on tester to developer ratios. Oh, we need this many people for this many developers. Well, how many developers are involved in an open source application? How would you know? How would you do any sort of estimation in that fashion? How many people would you need? There probably aren't formal requirement specifications floating around anywhere that could be used in some sort of parametric model